So in today's class, we are going to discuss the third law of Newton's. That is what Newton's third law of motion. So let us just brush up the first two laws, and then we'll move to the Newton's third law. So as we all know that Newton's first law will says that what net resultant force is equals to 0, or net acceleration is equals to 0. Means in the sense of when the net acceleration is 0, velocity must be what? All of you. Velocity must be, respond, velocity must be constant. Then there is no change of velocity. Rate of change of velocity is 0. Means acceleration is what? Everybody. Acceleration is 0. So that is what Newton's first law, which we studied. And Newton's second law we discussed till yesterday's class. That is what? F net is equals to, what is the formula? Change in momentum divided by change in time period. So this is what Newton's second law, which we studied. So now let us comes to the Newton's third law. So this is very popular law, and we used to use in our daily life many times. Yes, Newton's third law. So even if people don't know first law and second law, but third law, everybody will remember that. So anybody tell me what is that third law? What you studied in our class 9th? Newton's third law. Try to speak and participate in the class. That is what being a part of the class is always very important. Yes, Newton's third law. What do people knows? Every action there is equal and
Opposite reaction.
Equal and opposite
every
reaction.
action has equal and opposite reaction. So that is what which you studied about Newton's third law. But if you have been attended my classes from the class 9th, so you might be knows many points what I'm going to teach you now. So we all knows that this is what we can write in the form of action. Action is equals to minus reaction. That is what opposite. So opposite indicated by minus. So this is what we used to say Newton's third law. So of course you remember always before, even when I'm teaching the last chapter and this chapter also, action and reaction, if you want to exactly say what is Newton's third law means. So we all knows that forces are always existed as a what? Forces are existed in a, yes Pradosh?
Pairs.
Forces are existed in a pair. So what is Newton's third law means? Action and reaction pair. That is only called as Newton's third law. So we can say action and reaction pair is called as Newton's third law. Now, so then let us notice it. For example, so we all know that, let me consider there is a surface and I have placed some object who is having a mass m. So all of you observe very carefully, who is having a mass, how much? All of you? Mass m. Now we all know that if the object is placed on the surface, immediately two forces are exerting. What is the forces, everyone? One force will be downwards. We all know that force, which is equals to weight, which is equals to what? Mg. Then the another force which is acting perpendicular to the surface. What is the force, everybody? Who is to called as?
Yeah.
Normal. Yes or no? So we all knows that. Then is it means that we all knows that n is equals to mg. So both are equal. So that no displacement of the body either upwards or downwards. So does it mean that, of course we know mg is acting downward direction. Normal is acting upward direction. That is what action and minus reaction. So if weight of the object is acting downward direction, the normal force is acting upward direction. So does it mean that normal reaction and as well as mg is called as action and reaction pair? Anybody can tell? Is it called as action and reaction pair? That is what my question. Is it called as Newton's third law? That is what I'm asking. If you think yes, you say. If you say no, why? You have to say. Anybody's? At least say yes or no. What you are thinking? Is it normal reaction and weight mg is considered as action reaction pair? That is what is my question to you. Anybody? So let me consider free body diagram. So can you draw the FBD for this one? I want to know FBD for this diagram. So what will happen? So consider mass as a point object, and upward force, what is the force acting? Normal. And downward, what is acting? mg. Okay. So now, if you all notice it, here both the forces are acting in the same body or two different bodies. That is what my question to you. Is it acting same body or different bodies? Same body.
Same body.
Understanding? So the first point which you have to remember about the Newton's third law, 9th class, if you attended my classes and if you are remembered, so I used to mention you from that point, Newton's third law will says that every action, there is a equal, every action has a equal and opposite reaction. But action is shown by the one body and the reaction is shown by the another body. That is what we studied. Am I right, Mr. Pradosh? Involved in the class
Yes.
and active. That is what. So here, if you notice it in this case, both normal and mg weight are acting in the same body. So that is why it is not actually n and mg is not considered as a action reaction pair. Do you all understand what I'm saying? Everybody? All of you?
Yes, sir.
Next. So that is the first thing. So action and as well as reaction. Action and as well as reaction acts on different bodies or same bodies. Everybody. They must act on different bodies. Understanding? So action is need to shown by one body. Action is shown by one body. And reaction is shown by everybody.
Another body.
Another body. Then only it is called as Newton's third law. Do you all understand? Yes?
Yes, sir.
Narayan? That is what you have to remember it. So action is shown by one body and reaction is shown by another body. That is what we used to call as Newton's third law. Next. Second one. So observe the forces which is considered on this body. So one force is downwards. So what is the force we used to call? The force which is pulling downwards. We used to call something. Anybody can tell me? That is what called as gravitational force. And upward force we used to call as, what is the force we used to call as? That is normal reaction. Clear? So then, is this both are same in nature or different in nature? Gravitational force and normal reaction, both are same nature or different nature? They are not same nature. So it is not, they are not pair. Keep it in mind, Newton's third law, action and reaction pair are of same nature. Ellame purima, understand guys? Same.
Yes, sir.
That is what you should understand. For example, I will consider the same example. Look into the board, look into the screen now, all of you. They must be in what? Everyone? They must be in same nature. Clear? Now, I have been placed an object who is having a mass m. Now, this is the surface. Now, we all know that the object will exert the normal force on the surface. That is what, let me consider. The normal reaction force exerted on surface by the object. By the object. This is what we used to say object is acting downwards. Then the normal reaction exerted by surface on object. How it will act? Everybody. Surface on object. Yes, Mr. Rudreswa. Surface on object. It will act what direction? Normal reaction. Do you remember surfaces contacts? Normal reaction on, sorry, the normal reaction on B, object by surface is upward direction. Am I right or wrong, everybody? Do you remember when we are solving the contact surfaces? We have been made. All of you?
Yes, sir.
So the normal reaction exerted by this one, I will consider N, and this one is also N. If I consider this one is N dash, then this one is also N dash. Do you have done? Do you remember everybody?
Yes, sir.
That is what. So this is called as action and reaction. You can see that both are same nature. So this is also normal reaction exerted on surface by body. This is the normal reaction exerted by body on surface. Okay, sorry, on body by surface. This is on surface by body. So both are same nature. Then that we can say they must be in a same pair. Clear, everybody? Next. So always remember, forces are always exist in a what? They cannot be exist individually. So force always, how it will be? Always exist in what? All of you? Exist in a pair. Clear? So individually they cannot be. Now for example, same one I will modify as a something. This diagram I will modify something. Then you can say, all of you, it will be considered as a Newton's third law. Now for example, some body is there. I am having in my hand. Let me take the whose mass is m. Now its weight is actually downward direction. That is what mg I will say. So which is actually pulling by earth. Let me take earth is down. Now if I mentioned earth here, the earth is exerting the force pulling this body downward direction. Then we all knows that if the earth is trying to pull this body downwards, then this object is also exert the same force on this body. Am I right or wrong, earth? Everybody?
Yes, sir.
All of you? If the earth is exerting mg force on this body, then this body, of course, maybe it is smaller, and we all knows that earth will never fall to that, and only this object will fall towards the earth because of it having what mass? It has less mass. Clear? So from the Newton's second law, F is equals to ma. You tell me now, what is the relationship between A and F? So m by A, if you notice, sorry, F is equals to ma. F is equals to ma. So A is equals to F by m. Am I right or wrong, everybody? Remember all of you? Formula. So what is the relationship between A and F? 1 by m. Means mass is increases, acceleration is decreases. Acceleration is increases, mass is decreases. Both are inversely proportional to each other. So that is the reason always who will falls? The object will fall towards the earth, or earth will fall towards the object? Everybody. Object will fall towards the earth. If earth is exerting mg force on this body, then this body is also exert same mg force on the earth. Then one is action we can consider, and another one, what we used to say, all of you, this is called as reaction. Clear, all of you? Then this is called as, we will say, Newton's third law. Okay. So for example, let me consider I am having a attached string. You might be all notice that police recruitment and all, they have to climb the rope. Do you all remember that experiment? Everybody? Climbing rope. Yes, all of you? Police movies and all
Yes,
you can watch. So there is a long rope. There is a long rope, you can see. So now there is a boy who is trying to climb the rope. Now, so he is exerting the force on which direction? He is trying to climb the rope. So he is exerting force on which direction? All of you? Upward direction. Am I right or wrong? All of you? Yes,
Yes,
please.
sir.
Yes. So now, actually, this attached one, the rigid surface is exerting the force on something. Actually, it is above from the ground. So there is a force which is acting downward direction. That is what the force which is exerted by the string. So as soon as the boy is trying to go upward, the string will exert the force on what direction? The boy is applying the force on upward direction. So the string will exert force on what direction? Everybody. It will exert the force on? Yes, please respond. All of you.
Downward
Everyone.
direction.
So one you can consider. For example, the force exerted on the string by this rigid surface or whatever it is, let me consider that is what action. So then this force is acting downward direction. So the boy will go what? The boy will go what? All of you. The boy will go to the, yes, please respond. The boy will go to the what? Upward direction. So boy is doing reaction or action. If the thread, the string which is exerting the force downward direction means the boy is going upward direction because he is applying opposite. Action is equals to reaction. So reaction means the boy will climb or he will stay there only. Boy will start climbing. Am I right or wrong? As the string is exerting force in the downward direction, the boy is exerting force in the upward direction. So this is, I'm considering as action. Then this will become what? Everybody? That will become reaction. So like that, always remember, if the Newton's third law need to apply, we need how many bodies? Everybody? We need
2 bodies.
2 bodies. So it is not possible to see the action and reaction both by in a single body. That is a statement even 9th class I have taught you. So it is not possible to see the both action and reaction in the same body. Always action is must be shown by one body and reaction is shown by some other body. Am I right or wrong, everybody? Clear or not? Yes? Please respond.
Yes,
So that is one. Now, so let us solve the question so that you all very clear. So the question number, first question number 1. So let me consider there is a string which is hanging from the some surface which is having a string. Now there is a boy who wants to climb this one. So he started applying the force in upward direction and he started moving with the acceleration 2 meter per second square. What acceleration? Everybody? 2 meter per second square, and the boy mass is 20 kg. And as we all knows that acceleration due to gravity, how much? Is against to gravity. So what is the acceleration? 10 meter per second square. Clear everyone? So now as we all knows that the boy is exerting force upward direction means the string is exerting force in the downwards, always away from this point. What is that called as? The force exerted by string we used to call something. Anybody? Called as what? Please respond. It is called as tension. So calculate the tension in the string. That is what is our work. So let me see who will solve first. That's all. All of you, make it quick. So by applying Newton's second law also you can find it. Very simple it is. So the boy is going upward direction. All of you check it everybody. So draw the free body diagram. Let me consider this is the mass. Now body is going like this. So that is what we can say tension. So now boy is going upward direction only. So acceleration is this direction. So who is positive? This is considered as a what? Positive. And something is acting downward direction. Understanding? So as he is going up, something is coming acting downward. So what it will become? That is what everybody? Please respond. mg. Am I right or wrong? All of you. Then this is considered as a negative. So then what will happen? F net is equals to, fastly respond. F net is equals to m into a. So F net is equals to what? T minus mg, which is equals to m is 20 into a. So this is the one of the equation. Any problem for anybody? Do you all understand? All of you? Yes?
Yes, sir.
Yeah. Now we all people knows a value we know, g value we know, and m value we know. So cannot find the tension. Calculate the tension. So tension T is equals to mg will come, minus will come this side. What will become? It will become plus. Am I right or wrong? All of you. So 20 into a plus mg. So that's all. So 20 into a value is 2 plus m value is 20 into g value is 10. So which is equals to 22s are 40 plus 20 tens are 200. Okay. So 200. So which is equals to what is the newtons? How many newtons string? All of you. What is the string tension? The tension in the string is equals to how much? All of you? 240 newtons. Okay. So now two general things I will ask you. So observe very carefully. Now there is a string. There is a string. Okay. Now which is hanging freely. So now, if suppose, if the weight of the body, the weight of the body, which will cross, if the greater than the tension of the string, then what will happen, guys? You might be heard the things like, if you travel in the lift and all, you might be see, they'll mention 13%, 10%, 6%, or which is equals to 880 kg maximum. Like that, have you all checked it in inside the lift, everybody? They'll mention it, correct? All of you? Please respond. Now, yeah, suppose if I put more than this weight, what will happen? That is what? The weight is greater than the tension of the string. So what is the expected result for you people? You tell me. What is the expected result of you? Mr. Monesh, Aswita? If the weight is greater than the tension string, then what will happen? You should speak. The wire will strip. Yes or no? So like normal, suppose if a rubber band you have a rubber band and you cut this rubber band and you stretch, you can stretch suppose this much. Now if you are keep on stretching, after reaching certain point, what will happen? It will break. Am I right or wrong? All of you?
Yes, sir.
Yes, same way. Now, if the weight of this object which is climbing or whatever it is, if it is more than the tension in the string, what will happen? The thread will cut. Am I right or wrong? All of you? You have to speak. Yes, please. So the thread will break automatically. I no need to cut, just I am saying. So the thread will break, so you'll fall down. Am I right or wrong, guys? You have to speak. Clear?
Yes, sir.
Yes, sir.
That is what you have to remember it. So all of you remember, for example, I will say the breaking force of this object is the string is 150 newtons. How much? If I say breaking force in the sense of, if you are putting the more weight than that, then automatically it will be what will happen? It will be collapsed. Am I right or wrong, guys? All of you?
Yes, sir.
Yes. So if the breaking point is 150 and if he travels with the tension, what is the tension we got it? Tension, what is we got it? Tension equals to 240 newtons. Okay. Then what will happen, guys? Breaking point is 150, but he is traveling with a 240 newtons. So that the wire will cut or not? The wire will break or not? Everybody. yes, the wire will break so that it will be fall down. Or else, we can, even though mass is more, if acceleration is less, if I control the acceleration, then automatically I can control the motion. Am I right or wrong, guys? The string, everybody? So you observe very carefully. If one person is slowly climbing, there is no break in the string, even though his weight is more than the tension. So definitely there is some limit where you cannot see the break in the string, because you are balancing, your acceleration is extremely slow, so that you can slowly you can climb, even though your weight is greater than the tension. Clear, everybody? Understand, Amma? But you are traveling even though the less than the braking that velocity, then what will happen, guys? The braking acceleration, then even though you are having a, like what we can say is that the braking force point is 150. If suppose you are traveling fastly, you are climbing, forget about the mass, then automatically it will break or not? The string will break or not if your acceleration is very high? Everybody, please respond. That is what. So if you notice it, that is why you can go any kind of bridges, old bridges and all bridge, you can see that they'll put the speed limit is 30 km/h, 50 km/h. You cannot go more than that. Do you remember, everybody? Bridge starting, they'll write any kind of old bridges and all, because more than that speed, if the train will goes, what will happen? Or the car will goes, what will happen? The bridge will collapse. Am I right or wrong? All of you remembered? Yes, please.
Yes, sir.
Yes, that is what. So even though your weight is less, but if you go more faster, acceleration is high, so that there is a possibility for breaking the string or not? That is what my question. Anybody? Yes, all of you? That is what. Now, for example, let me take real life. You might be all watched. How many of you watched a movie called as a Rail movie? Like Mr. Dhanush, and as well as what's her name? Kirti Suresh movie. Have you all watched a train movie? Train.
Yes, sir.
Yeah, you might be all
Yes, sir.
remember that when the train is passing from the long bridges. So there is a Tamil conversation also, I can convey in English. So they will say that bridge is very old. So if you go little faster than the normal velocity, there is a velocity which you have to travel in this bridge, or speed. If the train will goes with the same speed, like what, because they are not regulating the train speed. So I think that bridge speed is maximum 40 km/h. If you travel with that speed, the bridge won't collapse. So now, but the train will travel around like 150 km/h. So when as soon as the bridge cross the train, the entire bridge will collapse. Do you remember, everybody? All of you? Yes?
Yes, sir.
Yeah. But here mass is not changing. The mass of the train is almost the same. Every day when it is passing, almost the same train. But what makes the bridge to not to collapse? It is traveling with a particular velocity when it is crossing the bridge. But suddenly, even though the mass is remains constant, but because of due to acceleration, do you all understand, all of you? Due to the acceleration, maybe the bridge will collapse. Am I right or wrong? Because of high acceleration? Yes or no? You all to speak. Clear, everybody? Yes? So,
Yes, sir.
even more mass, for example, I will put more mass than this, then also maybe this bridge will collapse, like same way like a string. Or else, even with the same mass, if I travel with the more faster, then also the bridge may collapse or the string may collapse. Am I right or wrong, guys? Everybody agree with me? Clear?
Yes, sir.
That is what. So, if the breaking point, if you know the tension, that is what breaking force or breaking point of a string. So you, even though if you are having a more weight than that, so you can move up without breaking the string. How, guys? By reducing the what? By reducing what?
Excellent.
Acceleration. Do you understand, all of you? Understand, Amma?
Yes, sir.
That is. So even though if you want to go up, even the string capacity is not. So by controlling the acceleration, you can reach that point. Do you all understand, Amma? All of you? That is what is necessary. Okay. Now, so the next question. I hope you all understand. Anybody having any doubt, you can ask me. So question number 2. So let me consider there is a roof, there is a hard surface, rigid surface, where actually I kept apple apple and as well as orange, banana and something. So there is a banana. So something I kept it. So now I asked one boy to go and take this apple, orange, and as well as, let me take apple, orange, and as well as banana. So there is a string which is attached to this. There is a string which is, how much? The string which is attached to it. So who is having a break point? Break, clear? Or maximum tension which he can attain. So which is T is equals to 1000 Newton. Evla Newton it can assist maximum, everybody? 1000 Newtons, clear? And there is a boy now, there is a boy who is trying to climb this to get this apple and orange and as well as banana. So his mass is 80 kg. Okay, he's not a boy, let me consider as a man. So he's trying to go up. So acceleration is upward or downward? Acceleration is upward. Am I right or wrong, everybody? So this G is equals to 10 meter per second square. So now, with maximum acceleration, a man can safely climb up the rope. That is what we have to find. With, okay, with WITH, with what maximum acceleration. So what is the acceleration symbol? A above. So acceleration, a man can safely climb, up the rope. Clear? That is what is your question. So anybody can tell how it will be? All of you? You have to speak it. So consider this man is like a PBD. That is what? Free body diagram. So FBD. Now one force is acting upward direction. That is what? Away from him. So what is the force which is acting? All of you. So one force, this is the man. One force which is acting downwards, mg. Upward force which is acting. What is that force? That is what we can say normal. That is actually not normal. So we used to consider as something. What is that called as? He is climbing up. So what is that actually? Everybody. It is actually tension. Am I right or wrong? All of you. So that is
Yes,
a tension in the string. And the boy whose weight is mg. So which is pulling downwards. So now, this is the forces are acting. So F net is equals to MA. So what is the net force? T minus mg, which is equals to M into A. Mass value is 80. Am I right or wrong, everybody? 80 into G value is 10, which is equals to M. Mass value is again 80 into A. So T value also we know that. What is the tension in the string? Fastly. Tension in the string, they have given something. Everybody. How much?
1000 Newton.
1000.
Newton.
1000 minus 80 into 100, 800, which is equals to 88. So which is equals to 1000 minus 800. How much it is? 200 divided by 80. So you can get cancelled 20. So 2 4s are 2 10s are. Next 2 2s are 2 5s are. So what is the answer? 5 by 2 meter per second square. So 5 by 2 means what, guys? All of you? 2.5 meter per second square. So if he goes with this acceleration, what is the acceleration? 2.5 meter per second square acceleration. So is there any break in the string or he can climb up? Anybody? Is there any break in the string or he can climb up? That is what my question. All of you. If a person is traveling with a 2.5 meter per second, is the person can climb safely or the string will break? That is what my question to you all people. Yes, please. So he traveled with the acceleration 2.5 meter per second, then there is no break in the string. That is what you should understand. Clear, everybody? So because
Yes, sir.
a person is balancing its acceleration. Suppose if he travel with more faster, what will happen? Automatically the string will break. Am I right or wrong, everybody? Yes,
Yes, sir.
that is what you should remember. So always free body diagram you have to consider for the body and you have to mention everything very properly. You have to make it equations. I think many times we are practicing. Yesterday's class, day before yesterday's class, everything is same only. So that is what you should remember. F net equals to that is one. So this is what about the question. So what is the answer? Acceleration equals to everybody. A is equals to how much? Fastly. A is
2.5
equals
meter
to
per second.
2.5 meter per second. So you can see that what is the how to find the acceleration and how to find what is that and how the body moves, what is the sign convention, everything you have to remember. Okay. Now the next concept which we are going to study is very, very important. So that is what weighing machine. How many of you know? How many of you are having a weighing machine in your home? I think many of you are having, or else at least you might be are climbing to check your weight always whenever you find a weighing machine. Am I right or wrong? Yes.
Yes, sir.
Yeah. So weighing machine, if you go to hospital or wherever it is, you can see the weighing machine will be having a display here. So whatever is our weight, exactly it will show. Am I right or wrong? Yes?
Yes, sir.
No. So let me consider this is my weighing machine. This is my weighing machine. So I have found that if a person will stand above it, it is a two-dimensional, you have to imagine. Okay, Rudresh sir, can you hear me? Now,
Yes,
so
sir.
a man is standing on this surface. So as we all knows that it is surface, mission surface. For example, I'll say my mass 68 kg. Okay. Now the surface is like a line surface. Now you tell me, all of you. So what is the force which is acting downward direction for him? Some force is acting downward direction. That is what we used to call as mg, Newton's second law. Am I right or wrong, everybody? All of you?
Yes, sir.
Now, mission is not a frictionless surface. It has some friction. So that is what we'll consider two surfaces. One is what is the first surface? All of you. One first surface is equals to weight. Am I right or wrong? That is what mg. So now the surface is exerting force on this man is, let me consider n1. What is to consider, everybody? All of you? N1. Then the man is also exerting same normal reaction force on the mission. That is also will consider N1. Or if you want N, and here also if you want N. Is it okay? Wa? Yes, please. Please
sir.
respond. That is what. So now if you observe here, what is the concept? Nothing. When you're standing on these weighing missions like that, so it's very simple. I will consider you are as a point object. So you are having up N and down. Down is having something commonly. What is that? Weight of the substance. Am I right or wrong? Others, everybody terima teriada? Please respond.
Yes, sir.
So the normal reaction is equals to mg. So that is the way. Okay, so you have to solve the numerical. So weighing mission, n is equals to mg. That is what the force which is acting upward and the force which is acting downwards. That is what both is experiencing by the body which is standing on the weighing mission. And two more things also here it is there. What is that? The weighing mission is the surface which is exerting pressure, which is exerting force on the man. That is what I assumed as the n dash. Then the force exerted by a weighing mission on surface. This what surface it is? The object on the weighing surface is, what is the second one? All of you. So the force exerting, that is also N1, normal reaction. So the surface, the mission is exerting force on surface, that is N dash. Then the surface is exerting force on N dash. Understanding force on man, that is called as also N dash. Is it okay, guys? All of you? Yes? Do you
Yes,
understand
sir.
or not? That is what. Now, if you take this weighing machine into the lift, so only one case I will teach you and I will wind up. Okay, all of you observe very carefully. If weighing machine has been taken up, weighing machine actually is present inside the lift. Where it is there, everybody? Inside the, yes, lift. Lift terima ellame. If you go everywhere nowadays, we have a lift. Am I right or wrong? Yes. So weighting machine inside the lift, and you all keep it in mind, lift is going up. It is going what? This is very important. So lift is going what, everybody? Going up. Because coming down, it is another different thing. So observe very carefully. Now, there is a lift I have. There is a lift I have. Just imagine. And there is a person here. So let me take some madman or whatever it is, or yourself. Let me take Manikyam, you can take. So now, a man is standing inside the lift above the whom, above the where, above the what mission? Yes, please. Weighing mission. Clear? So
Weighing
a man is standing above the stage with this man who is standing above the weighing machine. Now we all know this man, the weight of this man is exerting downward direction. What is that actually? Weight is equals to mg. Am I right or wrong? Everybody? Yes. If the mg
Yes,
is
sir.
acting downwards, immediately upward direction something will act. What is that?
Normal reaction.
And as we consider lift is going up, so acceleration is positive or negative, upward or downwards. Acceleration will become what?
Upward.
Positive. Clear? Let
upwards.
me consider this man is like a point object. Yes, Mr. Hari, what is the points you are finding? Please respond, Pradosh, Asida. So what are the forces acting on it? One is normal force, upward direction. One is weight of the body, which is downward direction. And acceleration is upward or downward? Acceleration.
What
Upward.
direction?
Upwards. Understanding? Lift is going up. Clear, Rudreswa? So then F net is equals to, what is the formula? F net is equals to MA. So F net means what? This is positive.